So in this one, in part B, we have y is less than or equal to x, and y is greater than negative x plus 1. This is kind of like two problems in one. You're going to graph both of these inequalities on the same plane using the same techniques we used above, and then the overlapping shaded region is the solution because both the points have to satisfy both inequalities. So the overlapping shaded regions represents the solution set or solution region, okay? So I'll just write that down. Graph both sets of solutions on the same plane. Step 2, shade in darkly the overlapping shaded regions from both inequalities. That's it. That's the solution set. The overlapping part that you shade in darkly, that represents your set of ordered pairs that satisfy both inequalities. So take the related equation to y is less than or equal to x. So if we take the related equation to y is less than or equal to x, what is that? Y is equal to x, right? That's actually called the identity function. If you replace y with f of x equals x is the identity function. Anybody remember what that looks like? Remember, it's the 45-degree line that splits quadrant 1 and quadrant 3 in half. Remember that? So why is that the case? Because if you just plot a couple points, what would be a good x value to plot? 1. What's an even easier one than 1? How about 0? So what happens if you plug in 0 for x? What pops out for y? It's the identity function, 0. If you plug in 1, 1. If you plug in negative 1, negative 1. So you end up plotting these points, right? And then draw the line between them. Okay, I'll try. Don't laugh. I'll try to do this freehand. Okay, solid or dotted line here, or dashed? Solid, because of the or equal to, the line itself is included in the solution set. Because of the or equal to, you graph a solid line. It's analogous to the bracket when you're using interval notation when you're doing a one-dimensional graph. This is a two-dimensional graph, right? So solid. So freehand won't look as nice as if when I bring out my ruler tool, but it's not too bad. Nice solid line. And then determine where to shade. Does anybody remember the shortcut? You could use test points. You wouldn't want to use 0, 0 here. You'd want to use one like 1, 0 or 0, 1. So test points would work, but does anybody remember the shortcut? When you solve it for y, in this case, the given equation is solved for y. It has y by itself. If it's y is less than or equal to something, you shade generally downward. Anybody remember that? So you shade on the part that includes all or most of the negative y-axis. So I can tell just by looking that I would shade this guy on this side because that's where that's where all of the negative y-axis is in this case. Now, if you don't buy that, you could use test points. If you plug in 1, 0, you should get a true statement, do you? So x equals 1, y equals 0, you get 0 is less than or equal to 1. It's a true statement. Shade on the side that contains 1, 0. Either way works. But that's not the answer because we also have to graph what? The related equation to y is greater than negative x plus 1. So what is that? Y equals negative x plus 1. What's a nice way to graph that guy? Does everybody see where y equals negative x plus 1 comes from? Just replace the greater than with an equal to in the second inequality. What's the easy way to graph that one? Y equals mx plus b. So what's the y-intercept? 0, 1 is the y-intercept. That's a point on the graph right away. I'll do this graph in purple. So 0, positive 1 right there, right? And then what's the slope? Yeah, so the slope is negative 1, so you can think of it as negative 1 over 1. So from that point in purple, you could go down 1, right 1. Down 1, right 1. Or you could go up 1, left 1. It doesn't matter if you think of that negative as in the numerator or the denominator, right? And then what kind of line do we use here? It's a strict inequality. So is the line itself included? No. So dashed or dotted line. So I'll try to do this freehand. Won't look as good as when I use the ruler tool, but that's okay. So keep going like that. That's supposed to be dashed anyway. And then using that shortcut, where would I shade? Since y is greater than negative x plus 1, generally upward, right? Which would be the part that contains most of the positive y-axis. I'll stick with purple here. So you could shade like this. Now, you guys, if you're using pencil, you could put the pencil on its side to make a nice shaded region. With this thing, it's hard to do. So I just shade it by making these parallel lines. Can you see where you get that crisscross region? Isn't that the overlapping shaded region? Okay. So I can use my highlighter tool to kind of show you what that region would look like. It's got to be the overlapping shaded region. So kind of outlining the border here. And it keeps going to the right, doesn't it? And then just shade it in. So what I'm saying is every point in that highlighted region, the overlapping shaded region, satisfies both inequalities. Does that make sense? And then it keeps going, but of course you can't draw forever, so you just stop it at some point. So it keeps going like this way, right? Not too bad, right? Get out your Crayola crayons and have a good time in this section.